We are going to take a little bit of a break from factoring and solving problems like this to take a look at quadratics, not in equations necessarily, but quadratics on a graph, okay? So what we're going to do for the next little bit is, not like today a little bit, but for the next few lessons, is look at quadratics when you graph them. And how do you identify quadratics? How do you know if something is quadratic? And then what that looks like, again, when you put it on a graph. Okay, so there's a lot of words on here. This is just a review of what we did. Anything that's a quadratic trinomial is going to go to what power? To the second power. If it's quadratic, that means it goes to the second power. The standard form of a quadratic formula is written like this. It has how many terms? Which makes it a trinomial. Okay, to be a quadratic, though, it just needs this one. All right, quadratic trinomial is 3 terms, but to be a quadratic, all you really need is the exponent of 2. All right? If it has an exponent of 1, what kind of equation is that? Like if you had something like this, 3x plus 2. Perfect, it's linear. So we've been doing linear for the whole first semester, and when you graph a linear function, what does it look like? A straight line. So what we're moving into now is graphing quadratics. So graphing something where an exponent of 2. All right, A, B, and C are just variables that we use to stand for the coefficients in front of those terms. What is a coefficient? What is a coefficient?
The coefficient is the number that's in front of the variable.
Okay, guys, he's not the only one here. You guys need to know this as well. So the numbers in front of a variable. So in this instance, 4 is a coefficient, and 3 is a coefficient, and 2 is a coefficient. If there isn't a number in front, does that mean there isn't a coefficient? No? What is the coefficient? 1. All right, if there isn't a number, we assume the coefficient is 1. All right, in this case, A, B, and C, what would A be? B would be -6. B is -6, and C is -3. Good. In this one, is this a quadratic? Yes, it's a quadratic. It just doesn't have what terms? B and C, which means we can assume B and C are not 1, 0. Okay? Because if you assumed it was 1, it would look like this. All right, so we can't assume it's 1, but we can't assume it's 0 because there's nothing there. Okay, so 5x squared is still a quadratic. Instead of a trinomial, it's a monomial. All right, what do they look like? It looks like a U. It's a curve. It looks like a U, and it's called a parabola. Everybody say that? Parabola. It is called a parabola. Not parabola, but parabola. All right, that makes it sound like a disease. It's not a disease. It is a graph that looks like a U. Okay, now if you zoomed in really far on this, you would see that it does come to one point at the bottom. So even though this doesn't look like there's a point because it doesn't look like a V necessarily, there is a point at the very bottom. Or if you flipped it, there would be a point at the very top. Okay, and we're going to talk about what that means starting the next class. This is what we call the parent quadratic function, y equals x squared. So again, why do we call it the parent? Because every other quadratic function is based on this one, okay? So the very basic quadratic function, y equals x squared, will look like this. What do you notice about it? Where is its point? At 0, 0, okay? Which is what makes it the origin, what makes it the parent function. It begins at the 0, 0, and then it goes up in both directions. Okay, so when something is a quadratic, it makes a parabola, which means it mirrors itself, right? The left side and the right side, if you folded the right side over, where would it land? On itself, okay? If it doesn't, it's not a quadratic, all right? So when you look at a graph, to tell if it's a quadratic, it has to mirror itself exactly. And that's going to come into play when we're trying to graph these. Go ahead.
Does this have to do with anything with similar equations?
What do you mean similar equations?
Where you draw the line,
Mm-hmm.
and if the equation works on the bottom part, it's similar to...
Maybe. We also know that, let's say, for instance, like we're right here. If this is 2 away from the axis, how far would it be over here? Like if this is 2, how far would this have to be? 2. All right, it has to mirror itself exactly, which means it needs to be the same distance apart from the axis. Okay, now this is again just the parent. So every parabola is not going to look like this, where it starts at the origin, but every parabola will make a U, and it will be an exact mirror of itself. That doesn't necessarily mean that the axis is always the line that goes up the middle, though, and we'll talk about that too. Okay, so how do we identify a quadratic? So I want you guys to think back to when we were figuring out if things were linear. Do you remember these tables? And you had to find the change in the x and the change in the y, and they had to be the same, right? We needed a constant change in x and a constant change in y. So you made these little things, and this was plus 1, plus 1, plus 1. So you're like, oh, we're off to a good start. But then what happened in the reds? Is that a constant change? No. So you would tell me, is this linear? No, because it doesn't have a constant change in y. However, we're no longer looking for linear, we're looking for quadratic. So when you're identifying a quadratic function, the way you do that is there should be a constant change in x, but in y, there's a constant change in the second difference. What is the second difference? What is the second difference, do you think? Take a look at the picture that's up here, the figure that's up here. Say that again? To what? So what did we do first with the reds? What was happening in the reds? You were keeping track of how much difference there was in the original table, right? What does the blue do then? Good. The blue shows the difference between not the original table, but the difference between the reds. All right, that's called the second difference. So essentially, to figure out if it's quadratic, check out your x's. Those should be constant. And then there should be a constant change in the second difference, which means you figure out the first one, and then you do the second one. And we'll do a couple examples of these because I know that it's kind of a weird concept. All right? Okay, so take a look at this example. So we're going to try to figure out if it's quadratic. So x's work the same way. So let's figure out what our change in x is. All right, how do I go from -4 to -2? Plus 2. How do I go from -2 to 0? 0 to 2 and 2 to 4. Okay, so far are we good? Yes, that's a constant change in x, so that's good. That's what we want. Okay, now, first difference in y. How do I go from 8 to 2? -6, then 2 to 0. Then 0 to 2, plus 2. Then 2 to 8, plus 6. Okay, well that's not constant, right? So it's definitely not linear. But am I done figuring out whether or not it's quadratic? No. Now I need to figure out if this change is constant. So I just do it again. How do I go from -6 to -2? Plus 4. How do I go from -2 to +2? How do I go from 2 to 6? So is that constant? Yes. So that's what the second difference is. You just do it twice. You find the difference once, and then you find the difference in the difference. Okay? So is this a quadratic? Yes. All right? So a constant x and a constant second difference in y. All right, so if it's quadratic, can it also be linear or no? No, it can't. Because if it's linear, what would the graph look like? A line. And a quadratic should look like a parabola. Good, a parabola. Okay, now, what about with the equation? If I just give you an equation, how can you tell if it's quadratic? Brendan? Has an exponent of 2. Does it? No. So is it quadratic? No. All right? So it does not have an exponent of 2, therefore it is not quadratic. However, just look out for this trick. Is this a quadratic? Yes. I don't see an exponent of 2. It is. It definitely is.
Because if you do the box math.
Okay, because this is not simplified. This up here, was there anything I could simplify? No, so then you can judge right away. Down here, though, you have to distribute it or do the box method to find out that it's x squared plus 3x plus 4x plus 12, which ends up giving you x squared plus 7x plus 12. So then that is, in fact, a quadratic. So just look out for that. Before you can just say, oh, it doesn't have an exponent of 2, you've got to simplify first. Okay, make sure that you can tell if it's a quadratic. Yes?
I just realized what we've been doing for a long time, where you say it has to add up to 7 and multiply by 12. All you have to do really is just add them up and then multiply them together to figure it out.
Yeah. I'm glad you're having that moment at all. I wish you'd had it 2 weeks ago, but yeah.
You don't have to do the box method if you know how to add them.
Totally. Oh, you mean like going back to this now?
Yeah.
Absolutely. Oh, I see what you're saying. I thought you meant factoring in general. I was like, dude, how have you been factoring if you didn't get that? Okay. So yes, absolutely. So what Brendan just said is like a shortcut now to foiling or doing the box method is just add them up to get the middle ones and multiply to get the last term. Absolutely, except if what? Not necessarily if it's negative, because then you just subtract, so that would still work. But what if I threw like a 3 in here?
Oh,
yeah, okay, so then that would throw it off. But yes, if they're a very simple one, absolutely. Like you don't have to do all this. You can just say, I know the middle is going to give me 7, and I know the end is going to give me 12. Absolutely. You made me real nervous for a second there. All right. Well, I just was like, what have you been doing? So much more work. All right. So how do I graph them then? How do I graph them? Same way you graph anything else, right? You put your x points, you put your y points, that's your coordinate, you plot your coordinates, and you move on. However, my x's and y's, in this case, aren't going to make a line, they're going to make a parabola. Good. Okay, so my x is -2, my y in my formula is 2x squared. They filled the table out for you already, so this one's really simple. You don't have to do any work. So what's my first ordered pair? -2, 8. So where would that be? Left or right? Left 2, and then up 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then the second point is what? -1, 2. The third one is 0, 0. Fourth one is 1, 2. And then I'm just guessing, but is the last one 2, 8? All right. How did I know that? Because it has to make a parabola, so they have to mirror each other. So if this first one is -2, 8, this one would have to be 2, 8. All right, so then when I draw it, okay, obviously you should try to actually hit the points that you draw. All right, but that can be challenged. All right, so there's our parabola. Now, the point is at 0, 0, so it's similar to the parent parabola, except what do you notice about it? It's like tinier, it's narrower. Okay, so it's narrower. We're going to talk about that, like how you could just look at a formula and tell. Do you guys remember when we did linear and you were like, oh, you would move it up 4? Rodrigo says, no, I don't remember that. When I would give you an equation, it would be like y equals x, and then I would say y equals x plus 4, and you were like, oh, I know this has to move up 4 points or whatever. Okay, so we're going to talk about that later. Okay. What do you do if I just give you the equation?
So first, if you just give us the equation,
Yeah.
you have to
Rodrigo? Pick real numbers. Does anyone remember what my numbers were? Esmeralda? Does anybody remember what numbers I say you should always do? George? George? Good. So 5 points, right? -2. It's even more important with a parabola that you do a couple negatives and a couple positives, because otherwise, if you graph only positives, your parabola might, like you might have this point and then 1, 2, and maybe like 4, 6. And if I just graph that, I could pretty easily think that that makes a what? a line. All right, and it might not be perfect. So with quadratics especially, it's really important that you do a couple negatives and a couple positives. So again, I'm going to recommend -2, -1, 0, 1, 2. All right, Esmeralda, did you have a question, or you were going to say those? Okay. All right, so what does that mean, though? Pick my points, then what do I do? Plug them in, right? All right, well, the easiest one is going to be 0, because 0 times anything is 0. So, okay, done. All right, now, the tricky part with exponents, when you put in negatives, what do I do first here? I have to do, so if it's -2x squared, and I'm plugging in a -2, how do I have to plug it in? In parentheses, because when I square this -2, what happens to it? It becomes, no. -2 times, okay, think back to order of operations. We start with p, parentheses, right? There's nothing in the parentheses. What's the e? Exponents, which means what do I do first here? The -2 squared or the -2 times -2? -2 squared. You have to do the exponent first. If I had to pick what 99 times out of 100 people's mistakes were, it is inevitably that people multiply these two first. That's not order of operations. So by all means, just put it in your calculator. It will do the order of operations for you. But if you put it in your calculator, what do you have to remember? Parentheses, all right, are really important. Okay, so what's -2 squared? +4. And then +4 times -2? -8. Okay, what about -1 squared? Would be 1. And then what's 1 times -2? -2. All right, what's +1 squared? What's +1 squared? 1. What's 1 times -2? -2. And last but not least, what's +2 squared? 4. And 4 times -2? Okay. Again, what's a good check to make sure you're doing it right? If it's a parabola, what should these do? Yeah, they should kind of repeat. There should be a pattern to them, right? It should start, like, you should be able to sense a pattern, especially if you're plugging in the same points. If I chose like -3 and then +2 here, it wouldn't be the exact same pattern, which is why I always choose these 5. It should be some type of pattern, okay? Because if it's not a pattern, it won't make a U. All right, so then all you have to do is what? Plot those points. And again, I would do these on a calculator. Like, there's no reason not to do them on a calculator. Even if you're doing them mentally first, just check your work, because people make mistakes all the time because they do negatives wrong, and a calculator will catch those mistakes for you. Okay, so -2, -8 is over left 2, but then what? Down 8. And then -1, -2 would be right here. 0, 0, still right there. 1, -2. And then 2, -8 again. Okay, so there's our parabola. Does anybody, I'm going to go back, and then I'm going to come back to this one. Does anybody notice anything about this one and this one? It's the same, but flipped, right? Does anyone notice anything about the equations? It's the same, but negative. Okay, so when it's a negative number in front, negative coefficient, what's going to happen with your parabola? It's going to flip. It'll open down. And that's what we're going to talk about tomorrow. Yes?
I just figured out something on the calculator. If you go to table and you type in the equation, what I just did, it gives you all the exponents.
Oh my gosh, what? Yes, it will. So you should do that.
So then you can easily graph it.
Totally. The only problem is those are all negatives. Can you keep going positive? Look at that. Maybe you should show everyone how to do that. How'd you do that?
You go to table.
Where's table?
You go to table, and then you type in -2x, 2, you press
So
just press enter all the way, and it gives you
Yeah. If you hit table on one of those yellow calculators, it'll give you a y equals equation. So you just type in the equation, and then it will give you all of these.
No more solving.
Man, don't you wish Miss Byrne had told you about that back when we started these? What?
How come you never told us about this before?
Because I want you to actually do the work. Because no one ever figures it out. I don't know. I'm the worst. You'll get to do a survey at the end of the year. You can write about this. All right. Okay, so I would like you to do these 4 problems now. Keep in mind, you can use the calculator. You can all explore the table function, but you still have to know how to graph it. Okay, you still have to know how to graph it. Go.